Hey, Bren here again for another video. Now, today I'm going to be talking about why the world isn't exactly what you see. And this is based on quantum mechanics, mostly. So, it has a physics background. So, if you don't know much about physics, I encourage you to look into it after this video. And some of the things I say here will make a little bit more sense. But let's just get into it. Senses are all we have, but that doesn't necessarily mean that we should trust them all the time. Just because they're our only tool to look at the world, well, I mean, we have to use the senses to look at it through any other tool. So we're always using the senses to understand the world at all times. But anyway, we shouldn't always trust them. The world is much different than it looks at first glance. You know, the world is very different than how it is when we see it. The physicist Brian Greene described it as looking at a Van Gogh painting. It's like looking at a Van Gogh painting through an empty Coke bottle. You know, looking through the end of it, and it just distorts the image so much that you can hardly tell what you're actually looking at. And the first instance of the world not being what we see that I'm going to talk about is we do not live in a local universe. Now, a lot of you guys might think that I need to, you know, grab my camera to move it, or to change its properties, I need to come in contact with it somehow. But that's not actually true. Well, for me it's true because I'm not quantum entangled with my camera. But in the world of quantum mechanics, the universe isn't local. So once you go to the subatomic levels, everything is different than how we see it in real life, or what you want to call real life, I guess. Everything is different. What I mean by this is scientists have discovered that a particle on one end of the universe can change the properties of a particle on the opposite side of the universe. This means that you don't have to come in contact with something to change its properties. You don't have to come in contact with something to move it around. You don't have to. You can do it from anywhere, basically, if those two particles are quantumly entangled. But it's hard to you know, have a large object that's quantumly entangled with another object, but it is theoretically possible. This has truly mind-blowing implications, such as the government trying to use psychics to locate objects. Before this experiment was looked at as, you know, kind of like it didn't really make sense. You know, how could they use psychics to discover something? Why would the CIA use psychics to try to locate objects? Well, it makes sense now because we have the science of quantum mechanics to explain it. Something within their minds must be quantumly entangled with the object that they're looking at. That's how they can know where something is when they can't physically see it with their eye. Now I'm going to be talking about how an object can be in more than one place at one time. And this is proven by the experiment, the double slit experiment. The double slit experiment is, okay, you have let's imagine two slits in a board or something like that. You shoot an electron at the slits. Normally you would think that the electron would go through one slit and, you know, hit the screen that's behind the board. The screen records where the electron hits. But what people have found is that the electron goes through both slits and it acts as a wave, as a probability wave, when no conscious observer is looking at it while it travels through the slits. But if someone looks at the particle, then, well, if someone looks at the electron, it turns into a particle and it has a position, a speed, things like that. It actually exists in our space. All I'm trying to say in this video is I want you guys to look into the world of quantum mechanics. I think that it will change your view on the world, in a better way. You'll have a better understanding of the world, and it's just a really cool thing to look into. You know, it's really mind-blowing, the experiments and the implications of the experiments, it's just crazy shit to think about, and I encourage you guys to look into it. And what even blows my mind even more than quantum mechanics is how so many people don't even know about it, and it's been out for, you know, decades. So that's basically it, guys. Thanks for watching. See you in another video.